Okay, so today we're going to be talking about antiderivatives. And so antiderivatives are pretty much what they sound like. They're the opposite of taking a derivative. So oftentimes when seeing a problem, you will be given the derivative and you must solve backwards to get the antiderivative. And so there's a pretty easy way to do this that applies to all equations. So you will always keep the constant the same if there is a constant in front of the variable. You will always add 1 to the exponent. This is opposite of what you do when you want to take the derivative, where you would actually subtract 1 from the exponent. And then you proceed to divide by that new exponent, and you always want to add a c at the end to account for any constant that was taken away when the original equation was derived. So the antiderivative is used in a lot of different places in calculus. You'll see it in integration and differential equations when you're solving for area between curves. It's very useful, so it's a skill that you must know. So now we're going to move on to some examples. The first one is a pretty simple one. So if we look at what we did up here, so we're going to keep the constant, so we know that we're going to keep the 2x. We're going to add 1 to the exponent, so that will become a 2, and then we're going to divide by that new exponent, which is also 2, and we're going to add a c at the end. And so this, obviously, since these two 2's cancel out, this can simplify to just x squared plus c. So that's a pretty simple example of the antiderivative, but now we're going to kind of move into a trig function, because this can be a little bit more complicated, especially when more variables are added in. But as we know from derivatives, usually you would use Santa Claus when working with cosine or sine. So usually this would become a negative sign. Instead, though, we're going to be going backwards, and we're going to be using, or this cosine is going to revert back to a positive sign. So becomes sine x, and then we're going to add 1 to the exponent like we learned before, and we're going to divide by that same exponent, and we're going to add a c at the end. And then this can also be simplified or rewritten, I guess, into 1/4 sine x to the 4th plus c. Either one is correct, but it's really up to your preference. So that is antiderivatives. Thank you so much for watching. I hope you learned something.